Hi, I'm Matt Winkler. I'm a group program manager on the big data team here at Microsoft. And today I'm excited to talk about U SQL. It's a new development language that we have for big data for .NET developers. So let's talk a little bit about what is U SQL. It's a new language that's designed to make big data development easy, powerful, and fun. A little bit of history, it's actually based on a language called Scope. This is a language that we use internally here at Microsoft to power our big data systems that allow us to do everything from indexing the internet to understanding how customers are using our services and our software. And a little bit of background on U SQL. If you think about starting with SQL, with the very familiar select from where syntax that you're used to when you write a SQL query. And the next thing that you're going to do is you're going to add data flow constructs to that, because oftentimes what we see is that data transformation and data production occurs across a series of stages or pipelines. And so we want it to make it very, very easy for people to put different stages of their jobs together. So we add data flow constructs to that. The next thing that we know is that as you're dealing with big data, you're dealing with a lot of data that looks different. And so we add the ability for you to read from a number of different sources and different types of files. And then the other thing is that we want to support schema on read. And what that means is that as you read the data out of the file, you're going to actually be applying the schema on top of that. And that enables you to have a lot of flexibility and agility as you are writing your jobs. The final stage that we've added to U SQL is to make extensibility really, really simple. And the way that we do this is by leveraging C# as our expression language. If you want to learn more about this, there's a great research paper that was published in the VLDB journal on Scope, and that link's available in this deck. So let's talk a little bit about why we created U SQL. Why did we create a new language? And as we look at the landscape, we really see two different things. We see a number of approaches for big data that are based on code, and then a number of them that are based on SQL. And each of these have their pros and cons. When you're writing code-based approaches for big data, so these are things like Spark or Scalding or Cascading or even MapReduce, we find that they can be very expressive, that there's a lot of control that you get, but because you're writing arbitrary code, it at times can be difficult to optimize. And you have to be familiar with the programming language and the development environment that's required in order to use those. This drives a lot of people to SQL-based approaches. So these are things like Hive or Impala. And what we see there is people really like both the familiarity of SQL, because quite frankly, lots and lots of people can write SQL statements. The other thing that's really nice about SQL is there's a lot of optimization that we can do when you author a query using SQL. The downside that we see to a lot of the current big data SQL-based approaches is that extensibility is really, really difficult. You have to write code that conforms to a certain set of constraints. It's tough to deploy that code. It's tough to debug it. And incorporating that into what it starts out as a very simple SQL statement becomes pretty difficult. And so these really define the key design principles around U SQL. The first is that we want that very simple and familiar SQL-based interface, but we want it to be easily extensible. And so we think that it takes the declarative nature of SQL that everyone's familiar with, that also gives us the ability to do massive optimizations at scale, but we extend that with all of the expressive power that you get inside of C#. Another interesting thing that we're doing with U SQL is the support for federated query sources. And so what that means is that it's very, very easy to reach out to an existing data source, say a relational database, and pull in data and mash that up with all of the other data that you're running your jobs on top of. Lastly, because we're based on C#, we think the syntax is familiar to lots and lots of .NET developers. And so for .NET developers who are looking to get into big data, who are looking to take their skills and use them as they start to process lots and lots of data, we think that USQL is a great place for them to start. And so now I've talked enough. Let's go ahead and dive into the demo. All right, so now let's start out and get started with writing USQL. So if we're inside of Azure, the first thing that we need to do is create a Data Lake Analytics account. The easiest way to do this is to go here to New. Under Data and Analytics, you can pick Data Lake Analytics. And then there's just a couple pieces of information you need to type in here. We need to type in what the name of our Data Lake Analytics account will be, point it at a Data Lake Store account, and then click Create. And in about 30 seconds or so, we'll have a Data Lake Analytics account up and running. I'm going to go ahead and just show one that I've already got and get started there. So here is my Data Lake Analytics account. And what I'd like to do is run a sample job. And we've got a couple of different sample jobs here. So this first one is going to query a TSV file. It's a tab delimited file. And here, this is our first USQL job. You'll see I'm extracting out some schema here from a certain file, and I'm reading it using a TSV extractor. And what that's going to do is extract out all of these fields from a tab delimited file. And then all I'm going to do is turn around and write that back out. Now, the nice thing about Data Lake Analytics is that it's very easy for me to run these USQL jobs. And all I have to do is set this slider for how much parallelism do I want when I run this job. For a very small job like this one where I'm operating on a very, very tiny file, I don't need any parallelism beyond just running on one node. But I can take this slider and I can slide it up really as high as I'd like it to go. In this account, I can go up to 250 compute nodes running in parallel. We'll leave it at 1 because I'm just moving a file. Click Submit Job. And what this is going to do is turn around and submit the file to the cluster that's running inside of Azure. And that job is going to start running. So now let's actually dive into another way to do this besides the portal. And so what I'm going to start out with is Visual Studio. So this is standard Visual Studio. I've got the Azure SDK installed, and then I've got the Data Lake tools for Visual Studio installed. And when I do that, I can create a new project that is of type USQL. And so this lets me go ahead and get started. I've got one that I'm already working on. And what I'm going to do here is do a little bit of analysis on IIS web logs. And so what you'll see here, I'm going to start off with a file that's on my local machine. And this just keeps track of a bunch of HTTP requests. So you'll see this came in on January 1st, 2014. It was against this website. It was going to this location, and a lot of standard information about an HTTP request. And what I want to do, similar to what I showed before, we have this notion of schema on read, which allows me to say, this is what the file looks like. And so I'm going to extract out each one of these fields, and there's a number of them in this file. Where am I going to extract it from? I'm going to extract it from this weblog log file. And I'm going to use a text extractor. And a text extractor is really great for operating on standard delimited text. And here, my delimiter is just a space. If we remember what that file looked like, it was just a space between each one of those. Now that I've got that data loaded up into this table, what I can do is actually run a query on top of that. And if I look at this, this looks pretty much like normal SQL. I'm reading out the year, month, and date. I'm reading the refer, the status, and then I'm counting how many hits were recorded against that. And then I'm doing a group by on that so that the aggregate works correctly. And then I'm going to go ahead and turn around and output this. And what I want to show here is previously the job that I submitted was running against the cluster inside of Azure. Now what I'd like to do is actually run this locally. And this is really useful when you're just debugging, when you're developing a job, when you want to learn the language, and you don't need to submit out a job that runs on 250 nodes. And so the way to do that is we set the environment here to run locally. There is a directory, which is the local run data root. And this is what our file system looks like. And so here you'll see I'm reading from samples data weblog. I have a samples data weblog. That's the file I'm going to read from. And so let's go ahead and submit that. So this is going to turn around. This will build the job to go run. Once it builds that job, it's going to turn around and then start running it. And you'll see here I'm operating on a very small file, so it completes very, very quickly. How can I know it completed? Well, I'm going to go look at this output path, users mwinkle output weblog summary. So users mwinkle output weblogs summary. And let's go ahead and open this up. I'm going to open this in Notepad. And you'll see here now, because what was I outputting? I was selecting the year, month, and day, the refer, the status, and the count. And so here is the year, month, and day. Here is the refer. This one came from forums.asp.net. It returned a status code of 200, and I had one of those. And so this is a really easy way for me to run this job, run it locally. I can set breakpoints, and I can do all of my debugging inside of my code. Now, the other thing that I can do is I can actually run this job on Azure. And so in order to do that, I select my Data Lake Analytics account. Here it's called mwinkle. And then you'll see under the Advanced tab, I can go ahead and set that slider. And so the last job that I ran, I used 109 degrees of parallelism. That's probably overkill for this job. So I'll set this down at 13 or 15, and we'll go ahead and run that. So now let's look at another example where we get a little bit more of the C# extensibility and kind of show that. So what I'm doing here is an analysis of chess games. And what I'm trying to determine is, does the starting color have an advantage? And I could write this in SQL, but this is going to be a lot of string manipulation inside of SQL. And what I'd really like to just be able to do is write some C#, because I can write that very, very quickly inside of C#. And the nice thing is that every value inside of U SQL is a .NET object. And so you'll see that I'm reading, I'm extracting a column, which is the string. So my row is going to be called column. And that's just a .NET string. And so that means inside my select statement, I can treat that variable. I can call any string method on that. And you'll actually see I get all the IntelliSense here. If I wanted to trim that, if I want to, go to upper, to lower, I've got the entire power of .NET available to me here. And so here what I'm doing is I'm using the C# ternary operator and the contains method in order for me to calculate the color of the winning team. And then I just extract that. And then I'm running a query here where I'm just selecting the result and the count, and then I'm running that, and then I'm outputting that to this file. And the really cool thing about this is I can run this locally. This is going to run on well, let's go ahead and look at it. So I look chess million base dash 2.2. And so here I'm going to go chess million base 2.2. It's a 1.5 gigabyte file. Okay, it's a pretty small file still, but I'm going to run that locally. And I submit this job. This is going to run again locally. And what this will do is this is going to take about 20 seconds for this job to run, because it's going to run across all the lines in the file. It's going to do that. It's going to do that calculation, and then it's going to compute those values. And so once this is done, what I can then do is go to that output directory, And then I can see totals biggest 100, and then I can see which color had an advantage when they started playing the game. Okay, and the nice thing about this is I can turn around and run this on the cluster on as large of a data set as I have. I've run this on a multi-terabyte copy of this file, and all I have to do is move that slider to the right in order for me to process more data faster. Okay, so now what I'd actually like to do is go back to that job that we first submitted. And what we'll see here, this job completed successfully. We see a graphical representation of the query plan, which in this case is pretty straightforward. And the one nice thing that we can do here is for a job that's executed in the service, I can actually play it back. And so what we have is a very simple tool that allows us to download a job profile and execute and replay that job on my local machine. And so what this will allow me to do is in 30 seconds, it will play back the job, and it'll allow me to see where are the various bottlenecks, what data skew issues I may have, and it allows me to see how my job is performing. The final set of tools that we have, you'll notice when I submitted that job earlier, I said, hey, I probably don't really need to submit with the slider set at 15. How would I actually know that? Well, we actually display a warning here which says you actually didn't need 14 of those. And if we go, we can actually see based on the usage that, hey, I probably only needed to run one degree of parallelism here. And what this allows me to do is this allows me to, on much larger jobs, estimate and trade off between getting my job done faster, but spending more money by allocating more compute nodes to operate in parallel. Okay, so we just finished up our demos there. We walked through a couple of different ways to author U SQL jobs. We ran them both locally and in the cloud, and we showed you some of the debugging capabilities in order to tune your jobs and run them at scale. So in closing, if you want to get started, go ahead, grab Visual Studio and the Data Lake tools for Visual Studio. File new U SQL project, and then go ahead and start writing your big data jobs. You can run those locally, and when you're ready, you can run them up on Azure and scale them out to run on as much data as you have. And really the way to kind of move forward from here is really to have fun with this. Find a data set that's interesting to you, find a data set that's got some interesting stuff about your customers or about your products, and start writing some jobs to learn new things about it. I'd like to thank you for joining me today, and enjoy the rest of the build videos.